before we even start class today is we're just going to do a little bit of review on what these kind of symbols mean, what we do for questions involving confidence intervals. So let's get started here. Now, I told you at the very end of class after the power went out that there were a couple assumptions that we had to have before we even did a confidence interval question. Can someone give me one of the assumptions that we have to even be able to do the question? Not the mean. Remember, it was the things that we had to do for the central limit here too. Okay, I hear standard deviation, but let's do the sample size one first. So sample size has to be bigger than what number? 30. And if that's not true, we can also have the normal population, right? So or the population being normal. Okay. I think I heard standard deviation. What was true about that?
We have to know about the
Yeah, right. So the population standard deviation or sigma is given. Okay. Now don't worry too much why this is an assumption. When we get into the next section, you'll understand why I asked this in the first place. Okay. Second of all, we have to know the critical value. How do we find the critical value?
The chart.
The chart, right? You just go in the chart and you figure out what the critical value is. So this is the easy one. Just look at the chart. All right, next we have to find the standard error. How do I find that? What's the formula? Good, right? And it's the same formula you used for the central limit theorem equation. And this is why you have to check those assumptions because you use it for the standard error. Okay. Next, to find the margin of error, what do I do to get this value?
Multiply the
So you take the critical value, and then you take the standard error. So the two numbers that you just found, and you multiply them together. So pretty easy calculation there. Okay, next when you actually construct your interval, you're going to take your margin of error and you're going to add it and then subtract it from something. What do we add and subtract it from? The mean, right? And more specifically, the sample mean, right? So you're going to take the sample mean, you're going to add the margin of error. You're going to take the sample mean and subtract the margin of error. And that becomes your interval. Okay. Now, normally the smaller number goes first and the larger number goes second. I don't really care as long as you get the right numbers. Finally, you have to interpret your interval using the correct wording. Does anyone remember the wording for this?
wasn't it we are blank percent confident that the sample
That's a sample.
sample
That's a sample mean. Close up. The mean, but what type of mean?
population.
Population mean, good, right? So the population mean, which you can just use the symbol for, you know. And what do we say after that? Yeah, between the two numbers that we got. So this is basically all you need to know to do confidence interval questions. Before we actually do an example, is there anyone who needs the notes? Right, anyone else? Right. You guys are better at keeping notes together than I am. I usually lose my notes right away. And I need to get myself set up here. Go over what we did before. We did confidence intervals. We watched the videos to figure out that it was very similar to the range game on The Price is Right. We know our symbols that we have to know what they mean. And we did a bunch of examples where we found a confidence interval and even interpreted them. But we actually haven't put everything together yet. And that's what I want to do in this class. Okay. So in this class, we are going to take an example and actually figure out how to piece it all together. Now, I am very sorry for the spacing here. For some reason, the PDF file like cut down all like the white space. So there's not much space to be able to do the question, but I think we should be able to be fine with the space that we have here. Okay. Now, confidence interval questions are usually going to give you a huge paragraph. And this paragraph is going to have all these numbers in them. And it's very confusing. So before I even do this question, I'm gonna read through it and then write down all the information that I'm given below the question, okay? Let's see, we have a machine and it fills cereal boxes and it's supposed to put 20 ounces of cereal in each box. Now, it's kind of hard to figure out what 20 represents from this sentence, so let's just keep going. Next, we have a simple random sample of 6 boxes is found to contain something. What letter does 6 represent? N, right? N is the sample size, so no, nice try there. N is going to be 6. Okay, and this sample is found to contain a sample mean of 20.25. What symbol is 20.25? It does have an X bar. Yeah. Oh, you saw the bar is a minus.
Yeah.
Wait, yeah, X bar. X bar is 20.25. Okay. Then it says, it's known from past experience that the fill weights are normally distributed with a standard deviation of 0.2 ounces. Okay, so it gives us a standard deviation. Is this the population standard deviation or the sample standard deviation? Yeah, and why is it the population standard deviation? Yeah, like, okay, yeah, we can kind of assume that the question's gonna give it to us in here, which is good. But in the next section, you'll actually have to figure out if it's the population or the sample. Now, the reason I know that this is the population standard deviation is because when they're talking about this number, it's not in the same context as when it was talking about the sample. It says, oh, it has a sample mean of this, and then it says something about past experience. So now we're kind of going away from what the sample says and what we know from the past, okay? Rule of thumb is if the standard deviation isn't in the same sentence as what we're talking about in the sample, or it's not like right after we talk about the sample, then it's gonna be the population standard deviation, okay? So I'm not gonna try to be too confusing here. Standard deviation is kind of explained way after the sample, so definitely population standard deviation. What's the symbol for population standard deviation? Not, it's the O with the line on top, right? So it's sigma. This is 0.2. Okay, we want to construct a 90% confidence interval for the mean. Take a look at the question. I wrote down every number except 20. What does 20 represent? Nothing, right? Now, I don't know if you ever taken like a lot of standardized tests, like the SAT and stuff like that. Questions in those tests normally have what are called misleading numbers. Okay, and what those are they're essentially numbers that are stuck in problems that don't have any use at all. Okay, so they don't help us solve the question. It's just a number in the question. Okay, yeah.
So I put the misleading numbers.
To make you suffer. Yeah, to trick you. The SAT loves doing this because they love making students get the wrong answer, but making them feel like they got the right answer. And I don't really like them. I actually got this question from the textbook, which is why it's in there in the first place. And I promise you, I won't put any misleading numbers on quizzes or tests or anything like that. Okay. I just put that in there because sometimes if you ever take a standardized test in the future, you might see some of those in there, and I just want you to be on the lookout for them. Okay, let's go through our assumptions here. The first question says, is sigma given to us? Well, is it given to us? Yeah, right, it's in the question. So I'm just gonna write, yes, sigma is given. We know it's 0.2. All right, next, is the sample size bigger than 30? No, right, 6 is definitely less than 30. So can we still do the question? Yeah, and why is that?
It says
Yeah, it says normally distributed in the question, right? So even though the sample size is less than 30, the question says normal, okay? Now, another rule of thumb here, it'd be kind of dumb for me to give you a question where the answer to this is no, and you can't do the question, because I definitely want to see you do this. So I probably will not give you one where you can't do the question. Okay. Next up, we have to find the critical value. Remember, the critical value is found using the chart in, I think it's page like 3 or something. Okay, so why don't you take a look at your chart? What's the critical value? Perfect, right? The critical value is literally on the chart. You look at the 90% portion of the chart and it tells you 1.645.
Can you find the critical value on the quiz?
Yeah, but I'll give you the chart. So you don't need to like memorize any of the chart values. Just look up on the chart, be like, okay, it's 1.645. All right, standard error. I asked you what the formula is, but it's right behind me, right? It says sigma over the square root of n. Okay, well, I already have all my symbols up on top of the page. I don't have to even read the question again. All I have to do is stick 0.2 up top and 6 on the bottom. Okay, now I recommend if you don't have one of those high-powered calculators, do the square root of 6 first, which I did not do, so I'll do that right now. And I got 2.45. Okay, and then once you're done writing that down, you can do the division and get 0.082. Okay, so that's our standard error. How do I find the margin of error? Yeah, multiply the
critical value and the standard.
yeah, the two numbers that you just found, multiply them together. Let me actually write this out for our notes. So take the critical value, take the standard error, and multiply them together. So 1.645 times 0.082, and that gives me a 0.135. Okay, the margin of error is the number that we want to find. Okay, well, we got that number. Making the confidence interval, no more calculations are needed. We just need to add and subtract. What am I adding 0.135 to? 20.25, right? So in order to find the confidence interval, you're going to take your X bar and you're going to add and subtract the margin of error. Okay, so I'm going to take 20.25. I'm going to add 0.1 or 0.135 to get 20.385. I'm going to take 20.25 and subtract 0.135, and that gives me 20.115. Okay. When I make my interval, it doesn't really matter which one goes first and last, honestly, but normally people put the smaller number first, and normally people put the largest number last. Okay, so that is my confidence interval. Does anyone want to take a crack at saying the interval in words? Ariel?
We're 90% confident that the population mean is between 20.115 and 20.3.
Perfect. Make sure that you use the correct wording. There are other phrases that work, but I like to just stay consistent. It's easier for me if I just have a phrase I could fill in the blanks and I don't have to think about what it actually means. So I'm going to be lazy. Instead of population mean, I'm going to write mu. And I'm going to say is between 20.115 and 20.385. Okay. So a lot of steps, but each step isn't too hard, right? You just have to know what to do at each step, and the individual steps aren't too bad, okay? Any questions on this example? All right, if you flip your page over to example number 5, I want you to try this one on your own, or in groups if you want. And I'm gonna give you a few minutes, very similar to what we did before, and we'll come back in a little bit. Let's come up to the front here. So very nice job as I've been walking around. One thing before we even start that I totally forgot to tell you on the last slide, I'm using the notes from my old 150 notes last semester. And last semester on part D, I told everyone to write their interval a little bit different than how I told you this time. This might be confusing, where it says write as the point estimate plus or minus the margin of error, and writing it in this form If you want to, you can write it like that, but we have the interval notation this time. So honestly, if you want to ignore that last part, go ahead and do that. All right, in this example, we have the mean test score for 100 students was 67.30, which I hope never happens in my class. Please don't make that the mean test score. Make me cry a little bit. The population standard deviation was 15, and we wanted to construct a 98% confidence interval for the population mean. Now, for this question, it kind of gave you what the symbols were. Usually, I'm not going to make you guess too much, but sometimes I'll use the word sample mean instead of X bar, so that's something to look out for. All right, so the first part was writing down all our information. I don't remember, I think Ellie wrote that one out. I'm not going to ask you to explain this one because I think it's pretty self-explanatory, but Ellie did a great job of just writing out all the information so we never have to go back in the question. All right, part A, who wrote up this one? All right, McKenna, do you want to explain why we wrote what you wrote down for the assumptions? Mhm. Perfect. So satisfies the assumptions. All right, going on. I asked Ara to write the critical value, which she found using the chart. Not much to explain there. And because of that, I also asked you to write up the standard error and the margin of error. Do you want to kind of take us through that?
Sure. For standard error, it's the standard deviation over the square root of n. Sorry, that was not like a square.
It's okay.
So 15 is standard deviation, so we're gonna divide that by the square root of 100, which is 10, to get 1.5. And then to get the margin of error, you multiply what you got from the standard error, 1.5, by the critical value, which is 2.326, and then we got 3.4.
Perfect job. Nice work there. Does anyone have any questions so far? Sounds good. Moving on to part D, this was actually figuring out what our confidence interval was. Jules, do you want to kind of take us through this?
Yeah, I just added
Mhm. Perfect. Honestly, these two numbers will be fine for a test or quiz. Normally people write the interval with like the lower number first and then this higher number second. But if you just get the two numbers, I'm good with that. All right, finally, we interpreted the interval in words. I forgot who wrote. I'm not going to ask you to explain that. I think it's pretty self-explanatory, but we use the confidence level to say we are 98% confident, and then we basically fill in the blanks to finish this. All right, any questions on example number 5? All right, I did this in my last class, so I'm gonna kind of go over the next page real quick. We won't do the examples because I want enough time for us to do our quiz review, but let's just talk about this last part here, okay? Now, I'm kind of gonna ignore the part on top here, but let's just say, for example, I have 2 confidence intervals, and one has a margin of error, I'm gonna say MOE, of like 2,000. Okay, so it's a really large margin. Okay, then I have another confidence interval that has a margin of error of, I don't know, like 0.0001. Okay, which one of these confidence intervals is going to be bigger? 2,000. Were you about to say that? Yeah, right. The margin of error is what we're adding and subtracting to an interval. So if I'm adding and subtracting 2,000, my interval is going to be really big, right? Now, if I add and subtract 0.001, my interval is going to be really small, okay? So bigger interval, if we have a big margin of error, smaller interval, if we have a smaller margin of error. Now, for other relationships, it's a little bit harder to figure out like what changing one does to the other. So in order to kind of make this easier to think about, I'm going to talk about the relationship between margin of error and other things. Okay. First of all, confidence level, which is that 98%, 80%, whatever percentage it is, we call that the confidence level. Okay. Margin of error has a direct relationship with confidence level. Okay. And what I mean by this, let's say my confidence level between two samples, let's say I increase the confidence level. Okay, what would happen to the margin of error? Would it increase or decrease? Direct relationship. Yeah, direct relationship means if you increase one thing, the other thing is also going to increase. Okay, so they do the same thing. Okay, on the other hand, if I decrease confidence level, what happens to the margin of error? Decreases, right? So they do the same thing. Whatever you do to the confidence level, the margin of error does the same thing. Okay. Next of all, we have the margin of error has an inverse relationship with the sample size. And what that means is it does the opposite, okay? So let's say I take my sample size n and I increase it. What happens to the margin of error? It decreases, right? So if I increase n, margin of error decreases. And I'm pretty sure it's easy to understand that if I decrease n, the margin of error will increase. Okay. Any questions so far? Okay, now this seems like a very simple concept. When we do the examples, for some reason, students get this wrong a lot. So we're gonna do some practice with talking about the relationship between confidence level, sample size, and margin of error next class. But for now, we have a slightly long quiz review that I want to start a little bit earlier.